On the geometry page, there is a parameter for geometry fillet radius. This is a fillet radius that is applied to the toolpath. The result is a smoother toolpath in tight areas and corners. The value is automatically calculated to 20% of the current tool diameter for iRough and iRest. For iFinish, 1% is calculated. Using the Modify Fillet Radius checkbox, a value can be entered either in percentage or value of the fillet radius. Here is the toolpath set to 50%. With the toolpath set to 1%, we can see tight areas with small toolpath. This is not preferred for roughing. In the Tool Data tab, we can see the feed rates and spindle speeds used for the current operation. When the wizard is on, all values will be set by the wizard. Override checkboxes are available for most parameters except feed XY and spin rate. These values need to be synchronized when using the wizard. The feed XY value sets the feed rate for when the tool is cutting at maximum step over. This feed rate will be the slowest feed rate while cutting. The feed XY max value sets the maximum cutting feed rate. This value can be used to limit the entire cutting feed rate of the operation. It can override the feed XY value. The feed finish value sets the finish feed for when using iFinish, where the final profile pass uses a separate feed rate. At the current time, the wizard does not adjust the feed rate for finishing. It is set equal to feed XY. The feed Z value sets the feed for the Z down movements and the helical reposition moves when down in the cut. The feed helical value sets the feed rate for the helical entry. The feed reposition value sets the feed for the reposition moves when down in the cut. The spin rate value sets the spindle speed for the cutting in XY. The spin finish sets the value for the finish spindle speed for when using iFinish, where the final profile pass uses a separate spin rate. At the current time, the wizard does not adjust the spin rate for finishing. It is set equal to the spin rate value. The spin helical value sets the spindle speed for the helical entry. On the Levels tab, there is a checkbox for Through Machining. During calculation of the toolpath, there are times where it is more efficient to separate an area than spiral on that area. When machining through the material, the separated area would break free from the material. Using the Through Machining checkbox, separation will not be allowed. In the Technology Wizard, there is a tab called Modify Cutting Conditions, where advanced control is available for the operation. The material database is inherited from the tool. Using the pull down, another material can be selected for the current operation. The tool material is inherited from the tool. The material cannot be changed in the operation, but an override is available for adjusting the cutting speed of the tool. The next set of values is calculated by the Technology Wizard. There are overrides for modifying the values calculated by the wizard, while maintaining synchronization across depth, step over, feed rate, and spindle speed. Max chip thickness sets and displays the maximum chip thickness for level 8. Minimum chip thickness sets and displays the minimum chip thickness for all levels. Max spin sets and displays the spindle speed for XY cutting. Cutting speed sets and displays the cutting speed for level 8 before the tool material adjustment. Required power at the motor sets and displays the power required for level 8. Minimum cutting angle feed sets and displays the maximum feed rate for XY. Reposition feed max sets and displays the feed rate to reposition when the Z is down. Surface area percentage sets and displays the maximum surface area for level 8. Maximum cutting angle sets and displays the maximum cutting angle for level 8. Minimum cutting angle sets and displays the minimum cutting angle for all levels. Level 1 max cutting angle sets and displays the maximum cutting angle for level 1. When using the checkbox to override a value, if the value entered cannot be synchronized, the field will be painted red and an icon will appear. When the icon is clicked, the closest usable value will be entered into the field and the field painted yellow. In the Technology tab, there is an area for offsets. The wall island offset value sets the amount of material to be left on walls and islands during the operation. When switching between operation types, this value will be reset to the defaults. The floor offset value sets the amount of material that will be left on the pocket floor. Morphing spiral factors. The efficiency slider is used to set the amount of morphing the spiral can achieve. The greater the value, the closer the spiral will be to a true circle. The entry rate slider is used to adjust the rate of entry into the material. The greater the value, the greater the length is to transition the tool into the full cut width. In the Technology Channels tab, there are parameters for controlling channels. The Island Moding radio button turns island separation on or off. Channel width is automatically calculated based on the tool diameter. The value is for all channels in the operation. Using the Modify checkbox, a value can be entered. Thin wall thickness is automatically calculated based on the tool diameter. The value is used to extend the channel width during the channel to remove thin pieces of material that may be left over after the channel is created. Separation factor is used to adjust the area calculation that is used to decide whether to separate an area, then spiral, or to remove the area with long passes. In the Technology Sort tab, there is a parameter for Advanced Sort. If multiple pockets are defined in one operation, this allows for sorting the sequence of when each pocket is machined. In the link page, there is a parameter for Detour Length. The slider is used to adjust the distance the tool is allowed to travel while down in the pocket. The Arc Size slider is used to adjust the maximum size of the 3D arc that is used to reposition from one cut to the next. The arc size is automatically reduced when needed. Z clearance is the amount the tool is picked up off the floor when repositioning from one cut to the next. The Fit Arcs option will fit arcs in the iMachining G-code. The cutting angle tolerance is used to group sections of toolpaths that fall within the tolerance, and then arcs are applied to that section. Even a small tolerance can greatly reduce the amount of G-code for machines with limited memory.